Hello everyone and welcome to our presentation today. My name is Paul Arsuf and I'm the founder of the Decentralized web project. We're building a decentralized communication and advertising platform, and we did release marketplace and collection of NFTs based on three-dimensional objects. But I will be talking about our project after ending this presentation. And I would like to notify you that the topic originally today was self-control and temptation, the secret of successful people. But like we're switching the topic, fortunately or unfortunately, and I think like what we're going to present today is more interesting. So what is the topic of today? The topic of today is theories of the mind applicable in building of an artificial intelligence. Wow. I think like it is, personally, I think it's more interesting than self-control and resisting temptation. But let's start right away. If artificial intelligence is intended to be an echo of human intelligence, then by implication there should be metrics by which you can gauge the success of the human intelligence as well. This raises the obvious questions. What are human minds supposed to do? What is the human task, so-called? And by what clear criteria would we measure human success or intelligence? If our goal is to create an artificial intelligence that is at least comparable to human intelligence, an AI agents are designed around measures of success on their respective tasks. Then it seems imperative that we discover such a task and accompanying metric for humans. Any general artificial intelligence, or AGI abbreviated, would be measured against the same overall benchmark by which we measure ourselves. Many possible candidates for matrix of human success have been proposed over the years. Unfortunately, all are either over generalizations which ignore numerous real-world cases, or they're too vaguely defined, capable of being applied even to contradictory tasks, and thus not useful for measuring performance in any particular agent. This presentation will investigate this core question that of defining the human task, and see if we can resolve the impasse by probing its underlying assumptions. But how did we get here? In contrast to their historical predecessors, like for example classical philosophy, religious doctrines, and etc., modern theories of mind all embed within them an implied functional purpose for the brain. This serves as a benchmark against which to measure intelligence. It is also a relatively recent paradigm in psychology. Ultimately, the fact that no theory of human purpose plausibly covers everything that the mind does should cast a doubt on the presupposition that such a purpose even exists. Perhaps it only appears to be so from our perspective, perspective of the human who, once a purpose has been defined for the mind, hope to designate any given mind as good, bad, better, worse, etc. That is the viewpoint of moralizing observer. A general human purpose, a meaning of life, may be a self-generating chimera, a projected mode of social censor of or individual approbation. To begin, here are four different most popular candidates for what the mind does. Candidate 1, the mind tries to optimize some metric. As mentioned at the beginning of this presentation, this is the most popular paradigm employed across machine learning research. Researchers first define a task, and within that task they hardcore a metric to act as a signal for success or failure. So like this loss function or reward. The AI model or agent must then optimize this signal in the quickest and most efficient way possible. This approach is meant to mirror our own human pursuits of everyday desires like money, food, pleasure, comfort, and etc. Unfortunately for proponents of this approach, human cognition does not always follow a process of optimization. Although we may, in a few cases and for limited time, try to optimize some vague value like personal income, in most cases we lazily do only the bare minimum necessary to get by. We do so-called satisficing. Whereas optimization implies the agent is continuously engaged in goal-oriented behavior, being led from the front, so to speak. Much of the time, we humans need to be relentlessly pushed from behind. We must be prodded in order to do or even to think about anything. This lazy behavior of humans could be explained as optimizing within constraints, for example, to reduce energy consumption. But such an explanation would then have the opposite difficulty: to explain why many people still expend precious energy on seemingly profitless pursuits or hobbies, like, for example, climbing Mount Everest or whittling figurines they will never sell. It seems that we can decide capriciously and on case-by-case basis when we will optimize towards any goal and when we will satisfice to act contrary to it. A valuable theory of optimization must therefore explain these individual policy choices within some higher level policy governing their selection. And the mechanism for that is not clear from the theory itself. So we are ending with candidate 1 and going towards candidate 2. The mind is a problem solver. This second paradigm defines the human task as one of solving problems, both real and imagined, as they come up rather than engaging in continuous global optimization. This would explain why humans tend to satisfy, since they only address problems as it becomes necessary to do so. The first question that arises is, of course, how the mind comes to know what is and what isn't a problem. Indeed, much in the time the mind is not solving problems, but rather defining them, such as when a child learns to feel shame at others' opprobrium or pride at their approval. This is not problem solving per se, but problem finding. And although such self-defined problems are rooted in deeper biological needs, framing cognitive behavior as problem solving necessarily begs the question, why does our minds define problems the way it does? In practical research, agents are generally given their tasks, i.e. problems, by a researcher. This task hard code their problem definition as well as solution definitions via rigid constraints. The concept involved, such as moving an object to a location or distinguish between images of dogs and cats, as well as what counts as having done so successfully, are directly injected into the agent by the trainer. In the real world, such direct intervention is, of course, unrealistic. Even in the context of school and education, educators cannot force their lessons on their pupils. There's little you can do for a student that simply does not care about the topic, or who mishears, or who misunderstands, or who misinterprets their teacher. In contrast with the supervised didactic paradigm, such as those used in training AI, ignoring the trainer is not an option for the agent. And an active interest in the lesson is not a prerequisite for an AI agent. Rigid problem definition are ultimately why we seem only to be able to create a narrow AI and not general ones. Consider that whenever we define a problem for an agent and gauge its intelligence accordingly, we are naturally compelled to introduce inductive biases which specialize for the task at hand. Since a special purpose algorithm tuned to the task will always perform better than a general algorithm. The agent's architecture and data pre-processing then becomes a large part of its success. The result is akin to the fable of stone soup, as data preparation and inductive biases end up doing most of the heavy lifting. To generalize an agent across multiple tasks, even ones we haven't thought of yet, one would have to find the common substrate to all problems. Or we must discover the inductive bias that helps humans solve the general human problem. This requires us to discover a common driver behind all tasks, which is what we had difficulty finding in the prior section. So we end with candidate 2 and we're going towards candidate 3. And the mind understands or models the world. This is another common paradigm in AI development. It is sometimes combined with goal-oriented behavior or task optimization, as in model-based reinforced learning. In other cases, it is trained as a standalone task. Truth and statistics regularly overlap here. Modeling the universe is done solely on the universe terms. Whatever the universe presents to the agent's sensory inputs becomes the standard or ground truth to be replicated in the agent's mental model. The problem with this paradigm have already been elaborated in many prior posts and research. In brief, not only is the task of world modeling intractable when applied to fractal complexity in the real world, it is simply not useful without additional task-specific cognitive structures that shape what is learned. Culling your world model is necessary to pare down the infinite universe to a subset of conceptualizations that matters to you, rather than merely what is statistically good or bad. And this is most clearly demonstrated by those abstract concepts that cannot be modeled as empirically given by the world, such as space, time, beauty, good, or existence. Such concepts must come from within the mind itself. The core underlying problem with this paradigm stems from the fact that all world modeling in humans is driven and shaped by our desire to learn. Any knowledge gained must satisfy such cravings for knowledge, which means the motives precede and drive the subsequent process of understanding. Therefore, understanding the world is not the fundamental layer of cognitions, the motives are. And although empirical learning is still a critical part of this process, no one lives exclusively in their own fantasies. It's not the whole picture, even when restricted to cognition. So we are going towards the last paradigm and candidate 4, the mind pursues spiritual development. The last option is generally ignored in scientific research, which shuns spirituality, either out of diplomatic prudence or because it has no scientific language to describe it. However, given that many people privately believe that spiritual growth and to a lesser degree artistic self-expression is their life purpose, it should not be neglected in this list. The problem, of course, is how to define it in a way that allows the hypothesis to be accepted or rejected not to mention applied to AI. Many people believe that spiritual understanding necessarily evades all definition. On the other hand, the fact that spiritual doctrines exist and exhibit common trends across the world and throughout history means the subject matter does not entirely escape description. Your entire worldview can, in such cases, change without your intending it to. The hidden roots of all conscious human experience, namely the causes of these transitions, precede the act of understanding itself and are largely beyond your immediate use and cognition. And since the endless problems of humankind have no final solution, we can never be sure we have reached the ultimate correct standpoint from which to survey truth. Spirituality provides a means to address this ceaseless self-transformation by facing up to the fact that the struggles of humans cannot be finally understood, nor completely controlled. Any spiritual doctrine is therefore a reaction to the issues of how our mind interacts with its environment, and it's not that interaction itself. This means spiritual exploration secondary to the original cognitive processes themselves, um, and thus not the solution the human tasks we're looking for. Spirituality is not the answer to the question of this post, only it directs itself to it. Despite being individually insufficient for our purposes, there is still something in each of these four different paradigms that should be acknowledged as valid. For example, one is task optimization. Although our minds does not try to optimize any known metric, it is still driven by underlying motives in almost any activity, even when modeling the world or applying logic and reasoning to that pursuit. There is likely a way of framing optimization that would at the limit define the human task. Second thing is the problem solving. Our minds may not be completely characterized as a problem solver by its moment-to-moment experiences composed of solving the problems it has defined and that it encounters. Self-defined problems can be viewed as derived long-horizon resolutions to more fundamental problems like hunger or pain. And in the same way, may be set of self-defined solutions. So depending on how we frame the theory, all of conscious life is an act of problem solving. The third thing we can derive from this presentation is the world modeling. Though objectively modeling the universe may not be tractable, all cognition about the world and all planning based on that understanding still arrives empirically through our senses. Our mind may select some subset of experiences that is most useful to it, but it does not invent anything from the whole cloth. Moreover, understanding of the world can be reframed as understanding it in such a way so as to achieve our goals, which matches what humans actually do. This would implicitly include planning as a part of the cognition, which and make the system complete. And the last thing we can derive is the spiritual development. Spirituality, even on its own terms, may seem like a dead end for scientific descriptions of the mind, since it apparently defies explanation. However, the pursuit of deeper knowledge or of the fundamental drivers of human experience is ultimately what this presentation is about. Such transformations, were it available, would be a key ingredient for any spiritual education to be effective. So, a truly successful spiritual project would entail an answer to the question of the human task. Each of these paradigms, which we put in this presentation, appears to have part of the answer, or perhaps is the complete answer, but in disguise, misunderstood or misconstrued. The goal of artificial general intelligence research is to pull this together in a coherent picture of a common underlying process, while satisfying the requirement for completeness that was the original motive behind this presentation. Sometimes the most obvious truths are also the hardest to initially recognize. As may be apparent to some listeners and viewers, the common threads that unite these paradigms have already been laid out in the process of doing the analysis we did. In addition to their elaboration across other posts of such as this presentation. Wishful thinking and judging truths are on a continuum. What you want to believe or what is useful to believe according to your motive shapes what you end up accepting. Any plans you create for resolving a problem are part of the act of world modeling. Understanding the world is the same as building casual plans about it. Thinking is therefore a form of control over the world. This combines problem solving with world modeling. Changes in your needs after what you judge to be reasonable, goal orientation and understanding are linked by never-ending transformation of motives. This combines goal orientation and world modeling with spiritual development, which was the last paradigm we discussed. Concepts are expression of underlying motives. We cannot define a given concept except as an interaction of our perceived needs with what reality provides. This combines goal orientation with world modeling. The creation of tensions as well as their negation is how the mind defines problem solutions pairs. Our flow or stream of mental events is guided by these broader changes in motives. This combines goal orientation with spiritual development. The goal of this presentation uh, has always been to provide enough practical details so one no longer needs to rely on purpose and can finally stop asking what the mind is for. Early on, we began by describing the necessary primitives such as attention, recreations, introspection. Subsequent presentations discussed how purpose-based thinking affects our judgment and interpretation, and how altering presuppositions can change the conclusions we reach. The best way is to describe the necessary primitives and their interactions in a way that allows them to be applied to all cases, from learning to solve calculus problems to learning to contemplate our own existence. This is why the variety of topics covered in this presentation have been quite broad, since no mental event can be neglected without neglecting the mind itself. Together in this presentation, we treat the mind not as a machine with a single purpose, but with a set of purposes and events which cumulatively appear as if they have multiple purposes. To unite and resolve the contradictions without the four paradigms that we describe above, that we first transcended any of them and question the most popular assumptions about how best to interpret what the mind does. It is unlikely that the same assumptions that have served so well for narrow AI cannot help in making general AI. And with this said, I'm ending this presentation. Thank you for coming. Thank you for listening. And I'm coming back to the beginning of this presentation, where I told you that my name is Paul Arsov. I'm the founder of the Decentralized Web project. I'm currently working on two different projects, and the first project I like to mention is our marketplace and collection of NFTs based on three-dimensional objects. With these three-dimensional objects, there has to be a special engine which loads and displays the three-dimensional object, and we from the very beginning we built our own 3D software engine instead of using popular game engines like, for example, Unity or Unreal. With our own game engine, 3D software engine, what it does, it loads, reads the file of the 3D object, it opens a window on a computer screen, it loads the file of the 3D object, and it starts animating the 3D object in a way of moving it in a random fashion around the window it did open. But in addition to this basic capability of loading and animating in a window, our 3D software engine have multiple additional capabilities. The first additional capability of our 3D NFT is the capability of speaking. Our 3D NFT can speak in one of three basic voices. The 3D NFTs can speak either in male voice or in a female voice or in a whisper kind of a voice. In addition to the three basic voices, there are three different flavors of voices. A voice can be spoken either in a normal speed or in a fast speed or in a slow speed manner. If, for example, we have a male voice and it is spoken in a slow speed manner, then this voice can come as the voice of a masculine person or the voice of an old person. And if, on the other hand, we take a female voice and it is spoken in a fast speed manner, then this voice can come as the voice of a little girl or the voice of a funny person. The second additional important capability for our 3D NFTs is the voice recognition capability. If, for example, you have a 3D NFT which is animated and moving in a random fashion around a window, you can issue your very first voice command to the 3D NFT to stop moving. And then the 3D NFT is going to stand still and stop moving. You can issue following voice commands to the 3D NFT to move left, move right, move up, move down, zoom in, zoom out, rotate. And then the 3D NFT is going to fulfill each one of these separate voice commands and move left, then move right, move up, then move down, come closer, zoom in, go farther away, zoom out, and start rotating. The next additional and important capability of our 3D NFTs is the capability of them having a basic artificial intelligence. Wow, really wow. You can ask the 3D NFT what is your name, and then the 3D NFT is going to reply with their name. You can ask the 3D NFT who are you, and then the 3D NFT is going to reply with who they are. You can ask the 3D NFT to describe something. For example, describe Web3 or describe decentralization or describe Russia. And then the 3D NFT is going to reply in few sentences about Web3 or about decentralization or about the country called Russia. The last additional important capability of our 3D software engine is the capability of projecting and displaying the 3D NFT in a way of stereoscopics. What stereoscopics means is that part of the 3D NFT is going to be displayed in red or reddish colors, and another part of the 3D NFT is going to be displayed in blue or bluish colors. Then you, the user, can come to our NFT marketplace website, and probably now is the time to tell you the name and the URL of our NFT marketplace. It is 3dnft.decentralizedweb.org. 3D NFT is typed in a way of the number 3 followed by the letter D followed by 3 other letters NFT, and it is altogether 3D NFT. Then there is dot, then there are two words, decentralized and web. They're typed all together, decentralized web. Then there is dot and it ends with org. Once again, 3dnft.decentralizedweb.org. On the top of this, the front page of our NFT marketplace, you're going to see a number of links, and one of these links is the link to accessories. When you click on this link, you're going to see that we offer special glasses you can click and order one pair of these glasses, and when you receive these glasses you can see that one lens of these glasses is red and the other lens of these glasses is blue. Then you can put these glasses on. You can request displaying of the 3D NFTs in a way of stereoscopics, and then you can see the 3D NFT as coming out of the flat two-dimensional computer screen, and you are going to see it in real 3 dimensions. So with this set, I am ending talking about our 3D software engine and our 3D NFT collection, but I'd like to mention a few things about our 3D NFT marketplace. In our marketplace, we have our own blockchain instance, and by running our own blockchain instance, then we do not charge our users to pay for deployment, to pay gas fees for deployment of the smart contracts of the non-fungible tokens, and our users do not pay gas fees for transactions of transfers of ownership from one user to another user. Our own blockchain instance runs Ethereum software. This is the same software which runs on Ethereum mainnet. It runs on Binance Smart Chain. It runs on Polygon Matic, and it runs on Avalanche Avax and many others blockchains. In addition to running our own blockchain instance, then we are detaching buying and receiving proceedings from sale from a single crypto coin, and currently we offer 4 different choices of payment for buying and receiving proceedings from sale of 3D NFTs. The current choices include Solana Sol, Polygon Matic, Avalanche Avax, and Qcoin, which is a big centralized crypto exchange. They have a coin called KCS. In addition to buying and receiving proceedings from sale in 4 different crypto coins, we have a second parallel and independent way of buying and selling of our 3D NFTs, and it is done entirely in fiat currency. Currently, we could, if you're the user, you come to our NFT marketplace, you click on our first collection, you see all of the objects in our first collection, and then you see one 3D NFT that you like. You can click on this 3D NFT, and then you are presented with a video of this 3D NFT, and drop down screen and button to continue. The drop down menu offers you a choice of payment with 1 of 4 different crypto coins, and a 5th choice of paying with fiat currency. Let's say you select paying with fiat currency, you click on the button to advance next. You're going to be presented with a screen which is asking you to put your number of your debit or credit card, expiration date, and CVC. Then when you click to make the payment, what is going to happen is it is going to be a transaction and conversion from your national fiat currency to US dollars, and this converted amount is going to be deposited in our bank account. We are going to follow this action with a second action and a transfer of ownership the initial ownership from our 3D NFT marketplace to you, and now you become a user of this 3D and user and owner of this 3D NFT. You can play with this 3D NFT for a while, then you can decide to put this 3D NFT for sale. Let's say there's a second user which comes to our 3D NFT marketplace. They browse through the collection of the 3D NFTs, and they like this particular NFT that you put for sale. So then the second user is going through the choices of paying with crypto or paying with fiat currency. Let's say they select paying with fiat currency, and they put click on the button to advance next. They put their debit or credit card, and they make the payment. What is going to happen then is there's going to be a transaction and conversion from the national fiat currency of the second user, which could be different from your national fiat currency and different than US dollars. And this converted amount to US dollars is going to be deposited in our bank account. So we are going to follow this action with a transaction and transfer of ownership from you, the first user of this 3D NFT, to the second user, and this second user becomes current owner of this 3D NFT. So then we are going to follow this action with the third action, and transaction conversion from our bank account and conversion from US dollars to your national fiat currency, and this transfer is going to be deposited in your bank account. With this set, I did describe in detail the second parallel and independent way of buying and selling of 3D NFTs done entirely in fiat currency. With this set, I'm ending this little introduction of our first project, and I can tell you about the second project that I work on. The second project was inspired by current expectation of exponential growth of electric vehicles and the need to charge these vehicles. Currently, these vehicles are charged in so-called gas station model, where electric vehicles are coming to some location with which has several charging stations, and the electric vehicles stop, connect to these charging stations, wait for a while for a period of time for charging, and then they leave this location. But I anticipate that with exponential growth of electric vehicles, there is ultimately going to be an insufficient number of these stations inspired by the gas station model, and I'm proposing a model based on the parking lot model, where electric vehicles stay most of the time. At the daytime, usually this is the workplace of the owner of the electric vehicle, and usually this owner works in a high-rise building with an underground parking lot, and then when this user leaves your workplace after the end of the workday, they go home, and usually they may be living in an apartment building with underground parking lot as well. And we're proposing a model where we're building a product which is a remotely controlled switch, which could be turned on and off by the user uh, having either a special card, token, ring, or their debit or credit card. Um, and this switch then is turning on electricity, and the user can connect and start charging their electric vehicle. With this product that we're in development and we're going to release very soon, we alleviate the problem of charging of electric vehicles when they exponentially grow in numbers. But there's a second and currently not that important problem, but that it is going to be become very significant and important problem in the future. Power utility have to balance demand with supply of electricity, and if suddenly the demand increases dramatically, like for example when there's electric there's a time of the day, for example after midnight, there's cheaper uh, electricity charge for consuming electricity. So there's an incentive for the users to start charging immediately at midnight. And if we have hundreds, thousands, or millions of vehicles connecting at midnight, then we have a problem on our hands with meeting demands for electricity of these hundreds, thousands, or millions of vehicles which want to charge it and at this same moment. That's why we have a remotely controlled switch, and we can give this remote control to the power utility or to the, for example, the owner of an office building, or an owner of grocery store parking lot, or the owner of other for example hotel place which has a parking lot which can have their people coming to this hotel coming with their vehicles. So our product can solve this problem with by remotely switching at a convenient time for the power utilities, so that they can meet they can turn on gradually the request of the electric for request for charging, and they can meet the demand for electricity of these exponentially growing electric vehicles. The name and the URL I like to mention of our second project is power.arstec.com. Power is the regular word which we use for power. Then there's dot, then there's Arstec, and I can spell it Apple, Robert, Sam, Tom, Echo, Charlie, Hotel.com. With this said, I'm ending this presentation, this introduction. Thank you for coming. Thank you for viewing. Have a nice day. Have a nice evening and goodbye.